Hi everyone and welcome to the second tutorial of our basic electronic modules. So our the second session or second tutorial is going to be upon the component identification. Means in basic electronics we have seen that there are so many components like resistors, capacitors, battery, switches. So this kind of components are there. So here in this session we are going to identify that which kind of material is which kind of element is which, and how you can name it and how you can identify them. So, in this session, we will identify different electrical components and their applications in this field. This is the table of content. First, we will see the introduction to the electrical components. Second, we will see the general purpose components. And third, we will see active and passive components. And in the last and fourth part, we will see the circuit and schematic diagram. Means how or a circuit is built and how a schematic diagram is made. So the first is types of electric components. So four types of electric components are there. The first one is passive, the second one is active, then is general purpose tools, and after that you will see the electromechanical tools. So first of all, what is passive component? So a passive component is the component which does not require external power source to run. So an element or a component which doesn't require a particular power source to run means these are the components which can work without particular or intended power source. For example, resistor, capacitor, and inductor. So they run without a dedicated power source applied to them. Then after we have active components. So the active components are those who require a particular power source. So these are the kind of components which need an external power source to run. For example, diodes, transistors, ICs, and MOSFETs. So these are the components which cannot operate without an external power source. Then after we have general purpose tools. So these are the kind of tools which we use as a helping hand in building a circuit. For example, wire cutter, soldering iron, jumper wires, and breadboards. Then after we have fourth part, which is electromechanical tools. So electromechanical. See, this electromechanical word is divided in two, is can be divided in two parts, which is first is electric and then mechanical. So these are the devices which carry out electrical operation by moving parts or by electric connection. For example, relay and switches. So in the first section we have seen the four categories. Now let us see the general purpose tools, that which are the tools which falls under this category. So the general tools used as helping hand, for example, cutting or welding or joining different parts in making the electric circuits are falls under this category. The very first one of this category or general purpose tools is breadboard. As you can see, this is how your breadboard looks like. So in the breadboard, you can see that in this first and this very last, these two sessions, this has one row, this has another row, and similarly here it is one row and the another row. See, you can see that here this section and this section, the both the sections are similar. So here from this point to this point, you can say the negative sign. From this point to this point, you can see this positive. Similarly, negative, negative, positive, and positive. So in breadboard, let us first see that how the connections or how the internal structure of breadboard is made. So in here in the first row, as you can see that whatever component you are going to connect to this point, see these aren't black dots, they are holes, and these holes are internally connected. So in this part, the holes in this first line and the second line, these holes from this hole to this hole. So these holes are internally connected in horizontal manner. So this hole, this hole, this hole, this hole, this hole. Similarly, continuously, this hole, this hole, this hole, this hole, and this hole. So from this hole to this hole, from this to this, they are internally connected through a conductor, right? Similarly, for this positive section, from this hole to this very last hole, they are internally connected in horizontal manner. This section and this section, these are similar. So generally this positive and negative, this section are used for battery or power source connection. So for example, if you are connecting your battery to the circuit, then battery connection must have here. Whereas in this both sections, in this section and this section, so particularly you can, if you can see that from A to E, and there is a dividing part over here, and from this F to this J. Okay, see this section is internally connected and this section is internally connected, but this both sections aren't internally connected, they are separate. So from this A hole to this E hole, here these holes, these five holes are internally connected in vertical manner only from A to E, not F. Only from the hole A and the hole number E, these are internally connected in vertical manner. These aren't connected in horizontal manner. These are only connected from A to B to C to D to E. So they are connected in vertical manner. Similarly, this in this part, this hole from F to G to H to I to J. These five holes are internally connected in vertical manner only. These are not connected from here to here. These are just connected in vertical manner. So here the other components are connected like resistor, capacitor, light emitting diode. This kind of circuit elements are going to connect over in this section and also in this section. Whereas this both section, this and this both sections are provided for battery or power source connection. So breadboards are an essential tool for prototyping and building temporary circuits. So this kind of breadboards are very useful where you can where when you are going to consider a experiment, or you are testing a circuit, or you are just practicing a circuit. So in that part you are going to use a breadboard, because you cannot connect any wire using solder, because soldering is kind of permanent connection. But when you are practicing, you are experimenting, or you are testing any circuit, you will require a breadboard. Hence a breadboard is an essential part for prototyping and building temporary circuits. Now this breadboard contains holes for inserting wire and different kinds of components. Because of their temporary nature, they allow you to create circuits without soldering. The holes in a breadboard are connected in rows both horizontally and vertically, as shown in this figure. So these holes are connected horizontally, whereas these holes are vertically. Similarly, these holes are connected vertically and these holes are connected in horizontal manner. Now our next component is jumper wire. So these are nothing but a small size cable. These are the small wires which are going to use in your circuit experiments or prototyping, where you are going to test your circuit or prototype any model, or just learning any circuit connection. So these are the jumper wires, and it has three different three different types. First one is female to male, then male to male, then female to female. Now, as you can see in the image, is in the female, in this female to male type of wire, you can see at the male type of side, you will see that there is a pin, and in the female side there is a hole. So you can identify by this difference that if there is a hole, then it is female type, and if there is a pin coming out of it, then it is male type. So every jumper wire has three different types: female to male, and female to female. So a jumper wire is an electric wire that connects remote circuits used for printed circuit boards. So these are the wires which are used to connect different parts with each other. Now, the another component is digital multimeter. Now, it is named as digital because, as you can see, this component has a screen, and the screen has digits, right? Now, as you can see in the picture, it has 000. So it has a display and it is giving you a result in a digital form. Hence, it is named as digital multimeter. Now, multimeter stands for, it is a kind of device using which you can measure many quantities. For example, you can measure an LED's voltage, or if the LED is damaged or not, a resistor's resistance, also a transistor's continuity, diode's continuity. So sol uh, using this only sol meter, you can measure many kind of magnitudes. So a multimeter is a device that is used to measure electric currents in ampere, voltage in volts, and resistor in ohms. It's a great for troubleshooting circuit and is capable of measuring both AC and DC voltage. And these are the knobs using which you can measure different quantities. The another one is battery holder. Battery holder means a plastic case which holds your battery, or you can say your cells. So a battery holder is a plastic case that holds battery from 9 volt. Some holders are enclosed and may have an on off switch. This is the simple one, but the another type of battery holder are there which has a switch over to it, which you can turn on and off. Then after you have testing leads. These leads are great for connecting components together to test a circuit without the need of soldering, also called alligator connectors. So these are the testing leads and also known as alligator connectors. These are different types of wire cutter or wire stripers. Wire cutters means using which you can cut a wire or lose a wire's upper casing, rubber casing. So wire cutters are essential for striping these stranded and solid copper wires. Thereafter, we have precision screwdriver set. So these are the kind of screwdrivers which we can use for losing or fitting of tiny screws, which we can see in some of gaming consoles remote control or small remotes. They are also known as jeweler screwdrivers and usually comes as a set. The advantage of this over normal screwdrivers is the precision tips of its driver. They are very handy when working with electronics that contains tiny screws. Then after we have helping hand. Now see, if you have seen the soldering iron or a soldering machine, you will know that this is something which is very grateful when you are soldering PCB or soldering the small kind of screens. Okay, so when working with electronics, it seems you never have enough hands to hold everything. This is where the helping hand or third hand comes in. Great for holding circuits or wires when soldering or tying. Thereafter, we have heat gun. Now, this is the heat gun which is used to shrink plastic tubing known as heat shrink to help protect exposed wire. Heat shrink has been called the duct tape of electronics and comes in handy in wide variety of applications. So this is the last tool of our general purpose tools, which is soldering iron. So as you can see in the image, there are two types of soldering irons. The first one is fixed voltage and the another one is variable soldering iron. See, in the fixed voltage iron, you can you cannot vary the temperature of this particular section, whereas in this variable type of soldering iron you can vary the temperature using this regulator, connecting this lead over here and connecting the cable of this to your switchboard. You can just turn on this switch, and after that you can vary the regulator, and as per your requirement you can change the temperature. Whereas in this type of fixed voltage soldering irons, you cannot vary the temperature. You can just plug this to your switchboard and switch on the switch, and you are ready to use the soldering iron. When it's time to create a permanent circuit, you'll want to solder the parts together. To do this, a soldering iron is the tool you would use. Of course, a soldering iron isn't any good unless you have solder to go with. You can choose a leaded or lead free solder in a few diameters. So, these are the soldering irons. Now, the third category is active and passive devices. So, let us see the active and passive devices in electronics. So the passive devices are some of the elements or the components which doesn't require a particular or a dedicated power source. So the examples of them is first one, which is switches. Now switches can comes in many forms such as push button, rocker, momentary and other. So their basic function is to interrupt the current flow by turning a circuit on or off. So these are the different types of switches. This is push button, this is toggle switch. So the main purpose or main function of any switch is to interrupt electric current, and therefore it will turn on or turn off the circuit connected to it. So these are the switches which doesn't require a dedicated power source to run or to function them. Then after we have resistors. So the resistors are also a passive electronic component. Resistors are used to resist the flow of current or to control the voltage in a circuit. So the main function of any resistor is to resist the flow of current or to control the voltage in a circuit. The amount of resistance that a resistor offers is measured in ohms. Most resistors have colored stripes. As you can see, these are the resistors. So this is the one resistor, this is the another resistor. Now as you can see that it has two terminals and it has colored stripes over it. Each resistor have different colored stripes onto them, and this color stripes denotes nothing but their value, the value of resistance. So most resistors have colored stripes on the outside, and this code will tell you its value of resistance. You can use a multimeter or DigiKeys resistor color code calculator to determine the value of a resistor. We have seen the digital multimeter, right, just previously. So using that digital multimeter, you can measure the value or the resistance of an unknown resistor. Now after resistor we have variable resistor. See, this kind of resistors has a fixed value, whereas these are the resistors whose value you can vary as per your requirement. So a variable resistor is also known as a potentiometer. These components can be found in devices such as a light dimmer or volume control for a radio. So you have all seen that radio or the music system in which you have a kind of rotary part which you use to up the volume or to down the volume. So these are the kind of variable resistors, or you can say the examples of variable resistors. When you turn the shaft of a potentiometer, the resistance changes in the circuit. Means as you start turning this particular section or this rotary part, the variable, the resistors, the resistance of the resistors changes, and because of which you can see the change in volume, or you can say the frequency or channel of the radio. Then after we have capacitors. The capacitors are also a passive electronic component which stores electricity and then discharge it back into the circuit when there is a drop in voltage. A capacitor is like a rechargeable battery and can be charged and then discharged. The value of the capacitor is measured in farad, nanofarad, and picofarad. The another one is inductors. So inductors are also a passive electronic component. An inductor is a passive electronic component that temporarily stores energy in a magnetic field when electric current flows through the inductor's coil. Then we have light dependent resistor. This is the another type of resistor. So the main purpose of this kind of element is to resist the flow. But how it functions? So it functions depending upon the light. So its function of resistance depends upon the light falling onto it. A light dependent resistor is also a variable resistor but is controlled by the light versus turning a knob. The resistance in circuit changes with the intensity of the light. These are often used in exterior lights that automatically turns on at dusk and off at dawn. So these are the examples. Now the another one is diode. A diode is a kind of, you can say, element which allows the flow of current in one direction and it blocks the flow of current in the another direction. The diode's primary role is to route electricity from taking an unwanted path within the circuit. Means if current is flowing through the unwanted path, it will block the current flow. Then after we have light emitting diode, which is nothing but an LED. So the LED stands for light emitting diode, a diode which emits light. A light emitting diode is like a standard diode in the fact that electrical current only flows in one direction. The main difference in is an LED will emit light when electricity flows through it. Means through this both terminals, or you can say the legs, whenever the current flows through here, it will emit light in place of heat. Inside an LED there is an anode and cathode. Current always flows from anode to cathode. So current always flows from anode, which is the longer one, and the cathode, which is the shorter one. So current always flows from anode to cathode. The longer leg of LED is positive, which is anode, and the shorter one is cathode. Then after we have relay. So relay also is a switch. A relay is an electrically operated switch that opens or closes when power is applied. Inside a relay is an electromagnet which controls a mechanical switch. Means it does only the turning on and turning off operation, but it does on the electromagnet basis. Thereafter we have active devices. So the devices which operates only and only when they have a particular or dedicated power source connected to them. And the first one is transistor. This is how your transistor looks like. It has three legs, or you can say three terminals. Transistors are tiny switches that turn current on or off when triggered by electrical signal. In addition to being a switch, it also be used to amplify the electronic signals. The transistor is similar to a relay except with moving parts. Means in transistor there are no moving parts, whereas in relay there are moving parts. So transistor also is a switch, but the switch is, or the function of this switch is controlled by the current or electrical signal flowing through it. The second active component is IC, which is integrated circuit. So this is how your IC or integrated circuit looks like. It performs its function whenever there is current flows through its terminals. An integrated circuit is a circuit that's been reduced in size to fit inside a tiny chip. This circuit contains electronic components like resistors and capacitors, but on a much smaller case. Integrated circuits come in different variations such as 555 timer IC, voltage regulators, microcontrollers, and many more. Each pin on an IC is unique in terms of its function. Means the each pin, these are the different pins of this IC, and each pin has its particular function to perform. So these were the active and passive component of electronics. Now let's move forward to our fourth part, which is circuit and schematic diagram. So what here we will see what is circuit and how one can make a circuit. So an electric circuit is a circular path of conductors by which electric current can flow. A closed circuit is like a circle because it starts and ends at the same point. So a closed circuit is like a circle which has a common starting and ending point. Furthermore, a closed circuit allows electricity to flow from positive power to the negative means ground without any interruption. So in closed circuit your current can flow through without any interruption. In contrast, if there is any break in the flow of electricity, this is known as open circuit. Open circuit means there is an interruption of current or there is any breakage or anything, because of which your current cannot be flow through the whole circuit. As shown below, a switch in a circuit can cause it to be open or closed depending on its position. So to give the circuit breakage mode or the connection pose, you can use a switch. Okay, so switch will perform this closing and opening of circuit. All circuits need to have three basic elements, which is voltage source, conductive path, and a load. See, here in this picture you have both the circuits. The first one is open circuit and the next one is the closed circuit. Open circuit suggests that in the circuit you have some breakage or something because of which the flow of current is interrupted. Here you can see if from this point, means this positive point of a battery, your current is coming out. Now from here it is going through this. Okay, now it has a connection and your current will flow through this and this. But here, as you can see this is the switch. Let me first introduce you that this is switch, this is a voltage source, this is your load, or you can say in this particular case your load is bulb, and the black wire, or you can say the black line, is your conducting path or a wire. For this open circuit example, you can see here from the positive terminal of battery your current is coming out. It is going through this path from here to here. Now at this particular part your connection is open, or you can say there is a breakage. Means the current will not be able to go through this terminal to come here to end its path. Means current is interrupted because of this open connection. Hence the bulb will not turn on because there is interruption in the path. Hence this is known as open circuit, and because this switch is open, your LED or your bulb is in off state. Whereas in this closed circuit, what happen is, from here your current is coming out from the this battery terminal. It is going through this path and coming over here to the first stage of switch. Now here your switch is closed, hence your current is getting a path to go through. Hence your current coming from here will go through this path, and it will also end its terminal, or you can say its circle, to this same point. And hence your current completes its path from positive to negative, and hence your light bulb will start illuminating. And hence in closed circuit you can say your load is turned on. But when your switch is in close, or the connection is open, your any load, or in this example your bulb will not illuminate. As soon as you close the switch, as soon as you close the switch, it will cause the current to flow through the circuit, and it will make a complete circuit or a complete circle, which in turn glows the LED or any load connected to it. Now, what is schematic diagram? This was circuit in the real, but what about when you are drawing a circuit in a paper? So when you are drawing a circuit in a paper, you have different kind of symbols for each element or for each circuit element. So this is known as schematic diagram. So these diagrams use symbols to illustrate what electronic components are used and where they are placed in the circuit. The symbols are graphical representations of actual electronic components. These schematics are extremely helpful for beginners when first learning circuits. So this is a schematic diagram of a circuit having a load, a bulb, a resistance, a voltage source, and a switch. So here is an example of a schematic that depicts an LED, which is over here. Then it contains a resistor to control the current flowing through the circuit. It is a voltage which provides a power to the circuit. This is a switch which is used to on and off this load or bulb. So this is how your schematic diagram or schematic representation done. So this is the schematic symbol. Schematic symbol, this is how you can represent or you can draw your resistor. This is a fixed resistor. This is a variable resistor, whereas this is a potentiometer. Now, as you can see, this is LED. This is a typical diode. This is how you represent a diode, a triangle, one one no, this one point, another point, and a straight line over here. This is a simple diode, but whenever there are two arrows going out of it, then it will be LED. Then it will be the representation of LED, because LED is a diode, type of diode, which eliminates or which emits light, means it is emitting light outwards, and hence it is known as LED, the symbol of LED. Whereas it is light dependent resistor, means it is a resistor, the symbol of resistor, and whenever the light falls onto it, it will start its function, and hence this is the symbol of light dependent resistor. This is switch, this is transistor, this is relay, this is polarized capacitor, this is non-polarized capacitor, this is light emitting diode, this is simple diode with anode and cathode. The straight line over here will known or will be symbolized as cathode, whereas this triangle is anode. Straight line is cathode. Battery, the longer one line is positive, the shorter one line is negative terminal. So this is one cell battery, this is one cell, this is the battery. This is a sinusoidal wave into this round, hence it is AC source. This is A means this is ammeter, this is V means this is voltmeter, this is G means this is galvanometer, resistance, variable resistance, bulb or load, this is closed switch. And this is the path here is open, hence it is open switch key, where the path is closed, hence it is closed switch key. This is closed plug key and this is closed tapping key. So thank you so much. This was all about our second tutorial. We will see you in the next one.